among technology enthusiasts and DIY maker communities. Raspberry Pi has become the preferred platform for many creative projects, with its compact size and powerful functions. The latest version of Raspberry Pi 5 has a performance improvement of 2 to 3 times and adds PSI. Although the Raspberry Pi 5 has improved overall performance, there are not many DIY maker works based on the Raspberry Pi 5 on the market. Today I will share some reasons. The high performance of Raspberry Pi 5 places higher demands on the power supply system. Compared with Raspberry Pi 4, the upgrade of Raspberry Pi 5 not only improves processor performance, but also includes add PCIe port and better USB peripherals driver capability. So we need to provide a stronger and more stable power supply for Raspberry Pi. Raspberry Pi 5 needs to use a 5V/5A power input that complies with the PD protocol. If other power supply solutions are used to Raspberry Pi 5, the USB current output will be limited to 0.6A, and there may even be low voltage current limit warnings, causing the device to restart frequently. Therefore, the power supply issue is currently the biggest difficulty in developing Raspberry Pi 5 robot. How do we solve the power supply problem? We can upgrade the power supply solution. Choose a power expansion board designed specifically for Raspberry Pi 5. Integrate the PD protocol and can provide a stable 5V/5A output, such as your Boom Power Expansion Board for Pi 5. This expansion board can transform 7V/24V battery input voltage to 5V/5A output, thereby powering the Raspberry Pi 5. And it has PD power supply protocol. There will be no problems such as USB limited current, system warning, and restart. Another option is to use the existing Raspberry Pi 5 robot expansion board, such as your Boom OS robot control board and Microros robot control board. Both robot expansion boards are optimized for Raspberry Pi 5, which not only solves the power supply compatibility problem, but also provides a hardware foundation for robot project. In addition to power board and expansion board designed specifically for Raspberry Pi 5, there are other robot platforms based on Raspberry Pi 5. Microros Pi 5 robot. Microros Pi 5 is an OS2 robot developed based on Raspberry Pi 5. With a 2DOF camera PTZ and TOF LiDAR, built-in OpenCV image processing and MIDA-pipe machine learning algorithms, which can realize robot motion control, AI visual interaction, SLAM mapping navigation, multi-machine synchronous control. We provides a new Raspberry Pi 5 power supply solution, which can provide 5V/5A power supply. Transbot SE. Transbot SE is a tracked robot, developed based on the ROS system. Equipped with a 3DOF robotic arm and a 2DOF camera PTZ. It is compatible with the Raspberry Pi 5 and built-in OpenCV image processing algorithms, MIDA-pipe machine learning, AI deep learning framework, and MoveAlt simulation platform. It can realize robotic arm handling, AI recognition, tracking, autonomous driving, robotic arm simulation control. Roastmaster Series. The Roastmaster Series is equipped with the ROS robot control board, which is fully compatible with the Raspberry Pi 5 and can provide a stable 5V/5A power supply for the Raspberry Pi 5, effectively avoiding abnormal situations such as freezing and restarting, with a variety of LiDAR and camera, as well as voice interaction modules for choice. The biggest difference between the Roastmaster series is mainly in ROS support and structure. DOFBot Robotic Arm. DOFBot Visual Robotic Arm uses Raspberry Pi 5 as core controller, OpenCV's image processing library, Jupyter Lab as development tool, and Python as main programming language. The integrated design of camera and robotic arm can not only realize color recognition and grabbing, but also perform garbage classification through ROS robot control system. The complex motion control of 6DOF serial bus servo is simplified. Dogzilla Robot Dog. Dogzilla is a 12-DoF desktop AI robot dog, which can feedback its own posture and joint angle and torque. The coprocessor combines the inverse kinematics algorithm to support a variety of motion gaits. Using Raspberry Pi 5. Supports Python programming and ROS2 system, and can realize machine vision, robot kinematics, LiDAR mapping navigation, race control. Muto Hexapod Robot. Muto RS is an 18DOF bionic hexapod robot based on the ROS2 system. Adopt Raspberry Pi 5 master control, equipped with intelligent bus servo, LiDAR, depth camera, RICE interaction module, and Raspberry Pi 5 power expansion board. It can realize robot motion control, AL visual interaction, map navigation, Docker container development, deep visual tracking, RICE interaction and other applications.